I picked up this industrial grade collector of dust, but it is missing tons of parts. So I'd like to see if we can use 3D printing along with some woodworking as well to bring it right back to life. So stick around. I've always wanted a proper dust collector for my wood shop, but they are terribly expensive to buy new, at least for a good one. This one came up on Facebook Marketplace and it was free, as long as I picked it up that day. Otherwise, it was gonna be scrapped. Now I know what you're saying, Mike, what is this beautiful paint color? But what you're actually saying is you probably overpaid for it. But my hope is that it will be far cheaper than buying something brand new, and as a bonus, I get to save something from being scrapped. It was originally running with a 3-phase, 3-horsepower motor, and the fellow who I bought it from tried to convert it to single phase, but the job never got done. When I got this home, it was not in good shape. First of all, it was caked with sawdust, but not just on the outside. As soon as I got it out of the van, a ton of dust came out from inside of there. Surprise, the dust collector actually has dust inside of it. So the shop vac cleaned up most of that, and then I gave it a quick power wash and a brushing as well with some soap. After I cleaned it off, it became clear to me that this was in much worse shape than I thought. The steel support legs were bent, so I used some clamps and some wood to straighten it out a little bit. The base was in terrible shape. The casters were missing and it was completely mangled to a point where I didn't think I could actually salvage it. But with a crescent wrench and a lot of hammer blows, I was able to get it to a point where it at least resembled some sort of shape again. It's not perfect, but I think it'll do for now. The dust collector with the filter bags was exactly the height of my workshop ceiling at 9 feet, so I had to shorten them a little bit, and I would have preferred to leave them exactly as it was, but it just wasn't going to be of much use to me if I couldn't move it around my shop. All that said, this isn't going to be a useful project without a good motor, and the original being 3 horsepower, I wanted something as big as I could get. And I happened to find this 2 horsepower, 240 volt farm duty motor for 125 bucks that looked about the right size. The shaft is 7/8 of an inch, so I think it's a little bit smaller than the original, but I think it's going to work fine for us anyway. The motor was a perfect fit. I don't know how that happened, but we're in good shape to go ahead with this project now. I purchased a new and flexible 25-foot 12-gauge cord and added a 240-volt plug to the end of it and tested the motor out, and it does work. The wiring on the inside is a little bit unpleasant to look at, but luckily there's a cover to conceal all of that ugliness. So there's quite a lot to do to get this back up and running. You can see here there's a front cover that's missing, so that is probably the first thing that we should get done. On the bottom I have an MDF plate, I have a cutout for a little peephole, and of course I have a big 3D print here, and I'm going to also have some covers. The covers are probably going to be made from TPU. So let's start off with making the MDF plate at the CNC. This is just some 1/4 inch MDF that I have, and this is going to be temporary because I don't really want the finished product to be MDF, but I also don't want to spend a lot of money not knowing if this is even going to work. And you can see my shop vac is not doing a great job of clearing up much of this really fine MDF dust. And this is really one of the reasons I wanted a proper dust collection system. We are a good ways into the print now, 55%. It's about a 12-hour print. We can start working on the next problem, which is that this is useless without an impeller. The original one was 13 inches in diameter. And with this being a 2 horsepower motor, we're going to go to a little bit smaller, about 12 inches in diameter. So here we have the central hub, and it's designed to be 3D printable. And I have the rest, it's going to be CNC machined, and I've even removed some material here just to keep it as light as possible. I like to use tabbing so that everything stays in place. And I'm just using wood glue to put this together, and then I will clamp it and let it set for a couple of hours to cure. And that turned out pretty nice. The prints have also finished and they look great too. The manifold is made from PETG, and I made it completely solid, and I can fasten it to the MDF with some M3 screws. The hub is made from PLA carbon fiber, and all of the prints are 100% solid. I need to strip off the paint and all the sticky residue from the original gasket because I need to do a little bit of welding. You can see here the original paint color, and I really like that kind of creamy color. Eventually I will paint it to match my drill press. I don't really know how all of this was originally attached because it doesn't make any sense at all. These are all through holes. There's no way to attach the final plate unless you were able to reach in with your arm, but you'd have to reach in around the impeller, and I don't see how that works. I'm not really sure, I just know it doesn't work for me, so I'm welding on some 1/4 20 weld nuts to be able to attach this together properly. I also don't know who did this, but the rim around here is absolutely mangled. The bottom edge is super sharp, and that's just not going to work. I want to mount a bag here, and I can't have that bag tearing on me. So I'm just going to use an angle grinder to straighten it all out, and I will just make sure that all of the edges are rounded over and pretty smooth. So I have this remounted with our weld nuts in there, and I've got the back plate reattached, and I also have a brand new gasket in there. The old gasket looked like that. And here is the finished impeller with a 3D printed hub, and I decided just to drill all the way through, and I used a little bit longer bolts, countersunk them in there. These are 1¼ bolts, and this turned out really well. Look how tight that is. But we still need to do one more thing, and that is to take this from just being a cord to having a switch mounted here. So what I've done is I've ordered a switch, and I've 3D printed a nice deep box. Let's go ahead and get this all assembled. I need to add in 2 heat set inserts. These are M4. I'm not really sure exactly where I want to put this right now, so what I'm going to do is leave the wire just a little bit longer than I need, and I can play around with the position, but I think I'm going to mount it probably just down here for now. I know it's going to be a bit of a reach, but I think it's also going to be a nice flat spot. And to mount it, I have this double-sided exterior grade mounting tape. Plug this in. There we go. And make sure everything is working. There's a little tiny bit of wobble, but it's not too bad. I don't think it's going to be a problem. And then it should spin this way, clockwise rotation. That's how I have it wired up. Now I need to get a bag on here, and the original was a big steel bin. I don't feel like lifting a gigantic steel bin, so they sell these, and it's the perfect size to fit on this. It's the moment of truth. I've set up a way of measuring the sound, because I'm hoping that this is not going to be as loud as my shop vac. It's plugged in. Let's go ahead and turn it on. So what were we, 77, between 77 and 80, depending on which way the shop vac was pointing. So here's some combination of MDF sawdust and a bunch of little wood chips here as well. So mainly pretty fine stuff. Whoa. So that worked really well up until the point where I put in a pretty big chunk of MDF, and it might end up doing some damage in there. If you do a lot of CNC work, you're going to have chunks like that do get sucked up, and they're going to interact with the impeller there. And well, for an MDF impeller, it may not last forever. So what I've done is created a much larger impeller. It's going to fit exactly into this housing perfectly. It's basically the same size as this one. So here is the new impeller. And if we put it on top of the aluminum, that it's pretty much the same size. So this just barely fits inside of here. So let's get this off. Now, see, that piece of MDF did not get sucked up. It just sat in the bottom there. Does not look like there's any damage. Just was a little bit noisy. So I've redesigned the central hub. It's a little bit larger. So along with this one being larger, it's also just a little bit thicker as well. All right, let's see how loud it is with the larger impeller. There's definitely something wrong with that, but I'm going to go ahead and just test the CFM anyways. So it was a little bit louder than last time, up around the 74 mark. Still not as loud, not nearly as loud as the shop vac. Okay, I'm not impressed with that performance at all, and I think one of the reasons for it is because I've created this manifold so that I can attach 4-inch pipes to it, but that's really the wrong way to approach this. It should have been fed directly into a large 6-inch or 5-inch pipe, and then only break off into smaller diameters near the machine. Possibly the bigger issue is that this motor runs at 1750 RPM, and I think these dust collectors typically run at 3500. So I think what I need to do is add more fan blades to compensate for it. But I'd actually like to go much better to that by using 3D printing to create fan blades that look more like the wings of a plane. They're also going to allow the air to release much easier at the very tip. I am making a new impeller right now. I'm just waiting for the router bit to show up. I need an 1/8-inch router bit. And I think the source of that vibration is actually coming from the CNC machine. So let me show you what I've done. I had never taken the time to plane down the spoil board, And over on that side, you can see there's quite a bit more material removed compared to this side over here. So that means the depth of the cut on this side was going to be greater than the depth of the cut on this side. With this area planed down, it should be very uniform now. And I have been nailing down my MDF on here just to make sure that it stays as flat as possible. So it might not be absolutely perfect, but it should be much better than the result I was getting. I have a mixture of super glue and epoxy. I'm going to super glue each into place on the base plate, and because they're curved, they should seat really nicely, so it shouldn't be too difficult to get the rim in place as well. I will line the outside with epoxy as well, just to make sure that the corners are completely filled in. I'm going to coat the inside. And I'll put a little bit more super glue and press the fins in place. I've already test fit them. That is perfect. Have a look at that fit there. That feels pretty good already, and I'll put the rim on the top shortly, but before I do that, I think I'm going to wait for this to set and put the epoxy on the inside here, just for a little added strength. Well, that was not easy to get on. The set screws that are in between here are just really difficult to access, and I was just using an Allen key. Before, I think we were at 77. So that is an absolutely massive improvement over what I had going on there before. Obviously more fan blades, and maybe the design of those fan blades being 3D printed, also having the curvature, and they have a very, very slight tip on them, kind of like the wing of a plane. Actually looks good, and it really sounds good, and it seems to perform pretty well. I think there's a lot more that we can do with this, but at least to get this machine up and running and useful, like it is right now, is awesome. Eventually, when the weather warms up, this is all going to be repainted, but I want to perfect that impeller design. So let me know what you think about what the fan blades should look like, and with a 2 horsepower motor and about 13¼ inches in diameter, what exactly you think would be the best solution for this. If you're curious about how much something like this would cost, the motor was $125, the switch $28, the wire $99, the plug, yes, the wire was very expensive, but it is nice wire, 12 gauge, the plug $15, the bag and the clamp was $61 total. The nuts and bolts were about $15, that includes the weld nuts. Filament total was about $25. I have some gas in there as well, maybe $25 worth of gas, and I have some electricity usage as well throughout this whole process, about $10 worth. And I have some MDF as well. I think that was $22. So overall cost $455 Canadian, and in US dollars it is less. Now I'm not quite done. I do want some fixed casters on the back. I want some casters on the front, probably locking, and they'll rotate around as well. I may end up eventually replacing the motor with a 3 horsepower motor like this was originally intended for, but I think the 2 horsepower is plenty good for me for right now. I want to repaint this all. I do not like the way that this looks right now, so I will do a little bit more work on this. I'm going to patch some of this as well. But for now, I have a heavy-duty Cyclone dust collector that is typically very expensive. They're in the thousands of dollar range. Now I spent $400 so far, and I don't even have a corrugated hose that I can use, so I do need to buy that still. It'll be around $50 or $60. But with that hose, it should get me up and running for what I need right now. Let's go ahead and do a little bit more testing. I'm going to send some chunks through here and see how those 3D printed blades stand up against those. But before we get to that, make sure that you like the video and subscribe to the channel if you are enjoying this type of content. This video is a little bit different than what I would typically do. It's a project video mixed with some ideas that I've had. I really want to use 3D printing for industrial type purposes. And so this is a bit of a test to see if they can actually stand up and be used for that. But more than anything else, it is the ability to prototype here at home for a really low cost and then get the final product made maybe from metal or some other material that will last a really, really long time. But theoretically, I could go ahead and order something and I think I'd be pretty happy with a steel version of that. But I think I'm gonna wait for you guys to let me know how bad or good my design is and if you have any better ideas as well. I have emptied my shop vac into here. That includes all the chunks from the CNC machine as well. So let's put all of this into the dust collector and see what happens. See how those blades stand up against some real big chunks of MDF that are stuck in here. And some other random things as well. I actually really don't know what is inside here. All right, I think I need to seal up this area just a little bit better. Maybe put a gasket material around there would help. But we can see a lot of fine dust in here. So let's open this up and see what it looks like inside and see if we broke anything. There we have it. It is a little bit dusty. Let's take a look. There's some junk stuck on here. It looks like some metal shavings. But nothing looks broken to me. Not even these very, very sharp tips. Oh, there is one right here. This very sharp tip broke off. Right there. I was kind of expecting that. Here's a piece of carpet. And if we look down there at the bottom, it's almost perfectly clean. I will say these are collecting a little bit too much fine dust for my liking. But as some of the larger particles come through here, it might actually help to clean some of that really fine dust off of there.
Overall, I'd say pretty good results, aside from this one little tiny tip that broke off.
I just want to quickly say thank you to each of my patrons for helping to support this channel and making videos like this possible. And thank you for watching this video as well. And we will see you on the next one.